You know, when you think about concrete, you probably think of something incredibly strong, right? I mean, it is literally the foundation of our modern world. It's the most used man-made material on the entire planet. But what if I told you that all of its incredible strength, the very thing we rely on for our buildings and bridges, hinges on one single incredibly delicate factor? Get it just slightly wrong, and a structure that's supposed to last for centuries could be in real trouble.
So, what is this secret weakness? I mean, we see concrete as permanent, as rock solid. This is the stuff we use to build massive skyscrapers and gigantic dams. But it turns out it has a hidden vulnerability. And the key to understanding it, well, it all lies in the recipe.
And you might be surprised to hear this, but it all comes down to the simplest ingredient in the entire mix: water. Yep, not the super advanced cement or the perfectly graded aggregates, but the amount of plain old H2O. If you get that one thing wrong, the whole structure is compromised right from the very beginning, from the inside out. Okay, so let's get into what this is all about. In the world of engineering, this critical relationship has a name. It's called the water-cement ratio. And trust me, getting it right is a crucial balancing act that absolutely every single concrete project depends on. So what exactly is this ratio? It's actually pretty simple. It's just the weight of the water divided by the weight of the cement. And here's the part you really got to remember. It's all about weight, not volume. This isn't like baking where you can be off by a little splash here or there. In structural engineering, precision is everything, and this weight-based ratio is the absolute key to quality. So, is there a magic number? Well, for really strong, durable concrete, a typical target ratio is right around 0.40. What that means is, for every 100 pounds of cement you put in the mix, you want about 40 pounds of water. It sounds so simple, right? But actually hitting that target perfectly, well, that's where the real challenge begins.
And that challenge brings us to what we call the central conflict of concrete. It's this constant battle between two things you absolutely need: strength and something called workability. The tricky part is, you need both, but one often comes at the expense of the other.
It's a classic Goldilocks problem, you know? If you have too little water, the mix is super stiff and just unworkable. It's like trying to mix a dry, crumbly dough. But if you add too much water to make it flow nicely, the final product becomes weak and spongy, kind of like a soggy cake that just falls apart.
Let's just lay out the trade-off here. A low water-cement ratio gives you everything an engineer dreams about: amazing strength, fantastic durability. It's also less permeable, which means it's better at keeping water out over the long run. The only problem? It's stiff and really hard to work with. Now, if you go the other way, with a high ratio, sure, it's super easy to pour, but the cost is catastrophic. You end up with weak, porous concrete that just isn't going to last.
And the impact on strength it's just dramatic. We are not talking about a small difference here. A tiny increase in that water ratio can literally cut the concrete's compressive strength, that's its ability to resist being crushed, in half. So why does that happen? Well, every extra drop of water that isn't needed for the chemical reaction eventually evaporates. And when it does, it leaves behind thousands of tiny little pores and voids that fundamentally weaken the entire structure.
So, this brings us from the controlled environment of the lab to the real world, the construction site. And out there, the biggest threat to a perfectly designed concrete mix is the simple, ever-present temptation of the water hose. Just picture this scenario because it happens on job sites every single day. The concrete truck arrives with a perfect low-ratio mix, but it's stiff. So, to make it easier to pour and finish, a worker grabs a hose and adds some water. It seems like such a harmless quick fix, right? But in that single moment, all of that careful, precise engineering is completely undone. The ratio is ruined, and that concrete will now never reach the strength it was designed for.
And let me be clear, this isn't just a minor oopsie. It's a fundamental violation of core engineering principles. There's a reason experts call it a major quality issue. It is genuinely one of the biggest risks to structural integrity in the entire construction industry.
So you might be thinking we're stuck, right? If a low water ratio makes the concrete too stiff, but adding more water completely ruins its strength, how do you solve this puzzle? Well, this is where modern chemistry comes in to save the day.
The solution comes in the form of chemical admixtures, which are often called superplasticizers. Honestly, you can just think of them as a kind of magic ingredient. You add them to the mix, and they make the concrete fluid and workable without adding a single extra drop of water. This is what allows engineers to keep that perfect low water-cement ratio for maximum strength while still getting the easy flow they need to place the concrete. So at the end of the day, these admixtures completely solve that central conflict we were talking about. They just break the trade-off. It means engineers can finally get the best of both worlds, the incredible strength that comes from a low-water mix, combined with the easy workability that's needed out on a busy construction site. It's a total game changer.
Which brings us to a final thought. We live our lives completely surrounded by this material, in our homes, on our roads, in our cities. And all of its safety, all of its longevity, it all comes down to this simple recipe. So the next time you look at a massive concrete structure, like a bridge or a skyscraper, you can ask yourself, did they pay enough attention to the water? Because that one simple detail, that's what's holding our entire world together.